we are going to find some kinematic equations with calculus. When you throw something upward, gravity slows it down, it stops it at its peak, and then pulls it back down. The only force acting on an object in the vertical direction is gravity, which causes a constant acceleration of about negative 9.8 meters per second squared. Mathematically, we can write that as A of t is equal to negative 9.8 meters squared if you want to write down some units. This is our acceleration function. And in calculus, acceleration is the derivative of velocity. So now we can try to integrate acceleration with respect to time. So we can say v of t, or velocity, is equal to the indefinite integral of a, which I'm just going to write a in this case here, times dx. And so now using what we know about integrals and solving indefinite integrals, we're going to rewrite this right here. And we're going to say v of t is equal to at plus c. And so now we can solve for this constant right here. Well, we can just say that when t is equal to 0, well, if t is equal to 0, we're going to say that the final velocity, or v2, or this one, this side, is equal to v1, right? The initial velocity right here is equal to the final velocity when t is equal to 0. So in the very beginning, when the object is thrown, obviously the only velocity is the initial velocity. So that means that v1 is equal to c. So now we can write this again. We can say v of t is equal to at plus v1. And this might seem familiar to some people who've already seen some similar kinematic equations. If I rewrite it like that, so that's kind of a little derivation of it. So now if we integrate this velocity function, we're going to get a position which is equal to the integral of at plus v1 times dt. So now we're going to say and so then now we can kind of say the same thing as I said over here. When t is equal to 0, the initial or the final position, or just at this position, it's equal to y1. It's like where the object was thrown. So that's going to be our c here. So then another thing, I'm going to rewrite a now with g, and obviously it's going to be negative because gravity points in downward. So for the last time, which is pretty similar, which is another one of the kinematic equations, but this is probably rewritten as y2 or just y. And this is all in the vertical direction. The graph that is shown here is our position function, and here I set v1 equal to 5, and obviously g is equal to 9.8, and then I set y1 equal to 0 because that's where I wanted the object to be thrown at. This line graph here is the velocity function that we created, which looking at it makes sense because velocity is slowly decreasing and then going to 0, which when the object reaches its maximum height, and then it gets more negative when obviously the object starts going downward. And then just for fun, I graphed the trajectory of the object here with the angle of 45 degrees, which gives it its maximum range.